So the topic here is measuring volume spikes here. So you can see I have the volume on my chart, and I also have the volume MA, right? The volume moving average indicator on here. And so the question is, how do you detect, when the volume exceeds 1.5 times the volume MA, or, how do you detect when the volume is less than half, right? Less than half of the volume MA. So, to save some time, I already have my chart set up a little bit here. So we're going to go through adding one more indicator here, but I already have the volume MA at 150% or 1.5 times, right? So the green hash plot right there is the volume MA multiplied by 1.5 times or 150%, right? So you can see that the green line is 50% higher than the volume MA indicator. So we're going to add one more of these, and this time it's going to be half of the volume MA, right, or 50% of the volume MA. So let me open up the indicators list, right? We'll take a look at how this is done on the chart, right? And keep in mind, guys, we don't provide training for NinjaTrader, so I will show this simply because it's kind of necessary for new people to understand this. But as far as any kind of follow-up questions, on how do you do things with the indicators on the chart and stuff like that, that's really questions for NinjaTrader support. Obviously the chart is a part of NinjaTrader, and adding indicators and nesting and things like that really is in the scope of NinjaTrader support here. But just for the sake of providing how everything is done here, we're going to go through this quickly. So so we can see, right, so here I had the volume indicator, and right below that I have the volume MA indicator, right? And of course they're all on the same panel, number 2. But then the green hash line, that is Chameleon. All right, so Chameleon is one of those free support indicators, that comes with BloodHound. And so with Chameleon, what we've done is, you can see the input series here. The input series, we've taken the volume MA indicator and fed the volume MA into the input series for Chameleon. So the shorthand terminology of this is nesting. So if you see this mentioned on discussion boards and things like that, quite often the terminology of nesting is used, right? So we're nesting the volume MA into Chameleon, right? So Chameleon is not working on price, right? It's not using the instrument price to do its calculation. It's using the volume MA as the input for doing its calculations, right? And so with Chameleon, the reason why we're using Chameleon to get 1.5 times the volume MA is because Chameleon has this scale value input, right? So 1.5, is 1.5 times whatever the input series is, right? So we're taking the volume MA and multiplying it by 1.5 times here using the scale value input, right? You can also do an addition or subtraction as well. So, right, so there's 2 ways to modify the input series with Chameleon, right? So that's one of the reasons why Chameleon is still around, because it does have this scale, which is a multiplier, right? If you're going to scale something, that's another way of saying multiplication or division, right? So if you put 0.5, that would be, dividing by half. And it has this addition, subtraction. Now, if we look down in the plots here, right, the only plot that is basically visible, right, all the other plots are set to transparent, so we don't see them. But the only plot that is visible is the close. All right, right? And it's called the closing SMA, which yeah, I'll skip over that just for the sake of time. And the reason why we're only using the close is because we've changed the input series, right? So basically only the closing plot or the close SMA plot is the one that's now valid, right? These other plots aren't going to operate because price, the instrument price, is no longer the input series, right? It's an indicator being fed into this. So now that means the way NinjaTrader works is that means that really the closing SMA is the only plot that's plotting, the volume MA, right? So what we're going to do is add another Chameleon here so that we can get half of the volume MA, right? So we're going to go to the Shark folder and we're going to go to Tools, and there is Chameleon, right? So we're going to add Chameleon here, and our scale is 0.5 because we want half of the volume MA. And so now we're going to change the input series, right? We're going to replace the NQ, or basically the chart instrument. We're going to replace the chart instrument with the indicator. So, all right, so we're going to open up the indicators here, scroll down to the volume, and there it is. So there's the volume MA right there, right? Now I'm just using the 14 period volume MA, right? So if you want to use a different period for your volume MA, make sure that you adjust that while you're changing the input series here, right? All right, so there we go. So we just selected it, and adjust the period, and that's it. We're done. Okay. So there you go. So now we can see the input series is now switched over to the volume MA indicator. And next, let's see here. Next, we just need to adjust our plots here. So let me set the high and low to transparent. And the SMA, let's see, since we're doing 50% of the volume MA, I'll make this red. And we'll make this a little bit thicker. And I'll show it as a hash line. And, oh, that's right. And don't forget to put it on the correct panel. So, all right. So, yeah, the panel here, we want it on panel 2. There we go. Okay, so there we go. So now we have the volume MA. We have a 50%, higher line of that and a 50% lower line of that. All right, so now we can actually start getting to the question, right? So how do we, yeah, this is a two-part question here, right? So simply, how do we detect, when the volume goes higher than the 1.5 times, right? Or maybe higher than the 50%. But then we also want to identify some conditions here. So, right, so how do we generate a signal when the volume moves from, okay, actually, yeah, so I did get some clarification. This is not from 0. This is from the volume MA to, right, the 50% above, right, or 50% below, right? So we want to know basically when, the volume is in this range here. So when the volume's in this range, let's grab an arrow. So something like this, how would we identify this right here? And let's grab an arrow. There we go, right? So the volume on this bar, right, is inside this range, and then the volume breaks outside above the range, right? It breaks above the 1.5 times the volume MA, right? So how would we identify that? And here we go. Here's another example. Or the other situation is, how would we identify this occurrence, right? There, let's put that little arrow there, right? So we can see the volume is below the 50% of the volume MA. Okay. Yeah, so there we go. So there's the two things we'll be looking for. Right. And yeah. All right, so let's get BloodHound open. And all right, first thing we want to do is put in a name, right? A name for this workshop file here. So let's hit the change button and let's adjust the date. All right, so there we go. So we have a file name to save all of our work to now. All right, so let's switch over to the logic tab here, and we can start working on the logic board. So the first thing we need to do is create a new logic template. So we're going to hit the new button there, and there we go. Let's see, I need some kind of a name for this. All right, so essentially we're looking for a volume movement, to the volume MA of 50% above or below. So, all right, so this is going to be done basically with a bunch of comparison solvers, right? So, creating this on the chart kind of simplifies it visually. So we can see, what we're doing is we're comparing the raw volume, right? The volume to the Chameleon indicator, right? Where the Chameleon indicator is set up, in a unique way to multiply the volume MA indicator, right? So we're looking for the volume to be greater than Chameleon, when it's set up as 1.5 times the volume MA. Or we're looking for volume, like over here, to be below or less than Chameleon, when Chameleon is set up as half of the volume MA. So we'll grab a couple of comparison solvers and set them up to do this. All right, let's connect that in. And let's see here. Let's give this a name here. All right. So we're comparing the volume to 1.5 times yeah, there we go, 1.5 times the volume MA. So all right, so for the inputs, so we could just plug in the volume indicator here if we wanted, but there is a type here of volume, so we can just switch the type over to volume like that. All right, now input B, this is where we have to set up the Chameleon indicator the same way that we set it up on the chart, right? So so let's open that up and let's go find Chameleon. All right, so there's Chameleon right there. And so let's see, our scale, we want our scale to be 1.5, like so. And we are going to be looking at the close plot, right? So we're using the close plot only. All right, so Chameleon is now set up. We adjusted, right, the properties here, and we selected the correct plot. So now we need to nest the volume MA into Chameleon, right? right? So we need to change the input series for Chameleon like we did on the chart. So, all right, so we're going to highlight Chameleon first, and then we're going to scroll down and find the volume MA. There it is. And with a single click, now we can hit the nest input button. Right, like so. There we go. So now we can visually see that the volume MA is now being fed into Chameleon. So, and also again, if you're using a different period for the volume MA, just remember to adjust the period here. So select the volume MA, on the bottom left here, and then you can change the period for the volume MA so it matches what you're using on the chart, right? And if you need to make an adjustment to Chameleon, just select Chameleon, highlight it, right? And then you can go in and adjust the properties for Chameleon over here. So, all right. So that's how we nest an indicator into another indicator within BloodHound, right? Or change the input series. So let's click OK. And there we have it. So, right, we can see that whenever the volume is above the green Chameleon, right, which is 1.5 times the volume MA, right, we're getting a long output, right, because the volume is greater than the Chameleon indicator. And anytime volume is below it, we're getting a short, right? So there we go. Now, volume is non-directional, right? Volume doesn't tell you whether you should be buying or selling, right? It's just tells you how many people are buying or trading hands, right? So we're gonna change this output to a non-directional output, right? Since volume is non-directional, we're going to change this to a non-directional output. So it's more useful, in a system, that, right, so it's more useful with other system rules or other trading rules that will determine, right, the direction of the trade that you're looking for. So we're going to adjust the short output, turn everything off, and turn on that, right? So we're looking for A greater than B, right? So both the long output and the short output are both the same, right? And there we go. So now we get a long and a short whenever the volume is above the 150% there. Right? So now we need to make one. Now we need to make a comparison solver for this situation here, where the volume is, excuse me, where the volume is below the 50% of the volume MA, right? So, all right, we did a lot of work here in setting up Chameleon and everything here. So let's take a little shortcut, and we'll go to the Solvers tab. And so there's our comparison solver. We can make a copy of it, like so. And we'll adjust the name first. So now it's going to be, 50 or half of the volume MA, 50% of the volume MA. And so now we just need to go into the indicators here and adjust them. So let's open up the Chameleon. And so now instead of 1.5, we're just going to go 0.5, like so. And that's all we needed to adjust, right? Is we're just adjusting the scaling value. And there we go. So there was our simple, quick adjustment to get the red line, right? So now we have a comparison solver, using the red Chameleon line here. So let's go back to the logic board. And we're going to go to existing nodes. And there's that new comparison solver that we just made, right? 0.5. Let's put that on the board. Now, when we connect that up, right, there's one thing that we didn't do here. So if we look at this, every time the volume is below, right, the half the volume MA, we're actually missing an output. And that's because we didn't go and adjust the outputs correctly yet. So we're going to turn off the outputs. And this time, A is less than B, right? What's A? Volume, right? The volume is less than the Chameleon plot, right, when it's below. So we want A being less than B now, like so. And there we go. So now we have, now whenever the volume is less than 50% of the volume MA, now all those conditions are marked. Right. All right, so now that we have our two main comparison solvers created, now we can actually go and look for situations. Let's see here. Yeah, look for when volume is, in the middle, and then volume either moves up or volume moves down. So we can basically add filters to these here. So let's see here. So we need to now detect when volume is in the middle, right? In this middle zone here. So we're going to need another comparison solver here. Let's see. Well, there's a couple of ways we can do this. Yeah, I guess either ways, both ways are fine. So I could just use the two comparison solvers I have, and then I could grab some function nodes. And I can grab function nodes to basically create, to detect when volume is in between, right, the two zones here. So I could do that, but, I think probably a more useful way is probably to have another comparison solver here. So let's create another comparison solver. So, no, actually, now that I think about it, no, you can't, we wouldn't be able to do this with one solver. So the reason why is because we had to use two different instances of Chameleon, right? So Chameleon has one setting for the 150% of the volume MA. And then we had to change the settings for Chameleon to get this 50% of the volume MA, right? So that's basically Chameleon with two different settings. So that means it would not be possible to make one solver with Chameleon with two different settings. So actually, I'm going to have to go with my original thought. So I got rid of that third comparison solver. And we'll just kind of go back to the two solvers that we have here. So what we want to identify is the bars here, right? The bars that have no output, right? So we want to identify when the volume is below the 150%, when there's no volume there. So to do that, we can take an inverter. Just simply take an inverter, plug that in, and there we go, right? So we have the opposite result now. However, these bars here, let's see here. I'll mark it with a dot. There we go. So, right, so the bars where the volume is less than 50%, those are being marked as well. So we now will have to take this comparison solver down here, right? And again, we want the opposite of this condition, right? We want all the volume bars that are above the 50% of the volume MA. Right, so we're going to do the same thing. We're going to take another inverter here, connect that in, right? So if we look at that, there we go. There's all the bars where the volume is above the 50%. But it also includes, the volume that's greater than the 150%. So the next step is to combine these two conditions here. And there we have it. So now we have the volume in between. There we go. So we can name that AND node there. So there's our detection of volume being in between. And so now we can move on to identify when the volume is moving from in between to either above or below, right, the 150 or the 50% lines there. So let's see here. So we will need to extend, right? So we need to take the output. Let's see here. Let me focus. Yeah, let me focus on this bar, right? So we need to take this output from this bar and move it onto the next bar, where the next bar, right, might move below the 50%, right? Or, right, take the output of this bar and shift it forward onto the next bar, where the next bar might be above the 150% line, right? So we're going to use the look back to shift everything forward. And what we're using is the displacement, right? So Ninja's displacement, right, it takes your indicator values and, right, it takes your indicators and shifts them forward X number of bars, So we're only shifting it forward 1 bar. So we're just going to use a displacement of 1 to shift it forward 1 bar. So, and I'll rename this so we know what it's doing. Right, so this look back node, we're just using the displacement of 1 there. And so now, if we grab another AND node and combine these two together, there. Now, there's probably something missing here. Yeah, I mean, there's definitely something missing here in the second part of the question here, where we're looking for a movement, of the volume to go from the volume MA, to 50% above or below, right? Because I guess what we're missing here is, there we go. Here's what we're missing. Yeah, here we go. So we did filter out basically this type of situation where the volume was below and then the volume spiked above, right, our 50% increase or decrease. So we can see that, yeah, we didn't get a signal in this situation here. So that's basically what we filtered out, like that. All right, so we need another AND node here. We can do one more, connect that in, right? So now that is when volume goes from right inside the range to outside the range or below the range there. So volume is inside the range and then it goes outside the range or below the range. Oh, there we go. So here's a situation where the volume is above the range, right? And then it suddenly drops below the range. And so there's no signal there. Right. And so now the next step here is to combine both of these with an OR node. There. And so now we can see everything together. There we go. So there's the signals when volume goes from inside the range to above the range, and when volume goes from inside the range below the range together there. All right, so there we have it. So there's a redo or a refresh of detecting, volume spikes kind of based on a percentage of the volume or a percentage of the average volume. Now, I'm sure somebody's going to come along and say, well, I want to narrow this range, right? So, this range in here, I don't want it to be, the range to be 50% to 150%. I want this range to be maybe a little narrower. And that's easily done. You would just need to create, right? So this this logic. Let's see if I can grab that. Yeah. So this logic here is what creates the range, right? So if you wanted to create a narrower range, well, what the heck, it won't take long to make. Let's just go ahead and make this here. So yeah, if we want to make a narrower range, I'm just going to copy both of these solvers here. And so let's do something like this. All right, there. So we're going to make a range, that's 1.25 times, to 75%. Right. So we just need to go in and adjust the scaling value for both of these solvers. So let me go into Chameleon and just quickly adjust the scaling value, right? So there we go. So there's 0.75 now. So there we go. So I have two new solvers that make a tighter, narrower range, right? And so now let me just put those on the board. All right, there's one. Let's grab the other one, like so. There, so we'll put those in the middle. Now we just disconnect these. Like so, right? And let's take a look, right? So we're looking at remember I named this AND node volume in between. Right? If we look at it, right, this is telling us when volume is inside the range. And so now, let's see if I can find an example. Yeah, here we go. So there we go. We can see here, right, there's no output because volume is slightly below that narrower range. There we go. Right here, volume is ever so slightly above this narrower range that I created there. So, right, so there we go. So if you want to use a narrower range, right, you just have to create two new solvers, that identify that smaller range there.